Today's lesson we learn rock excavation, and we have 5 learning objectives. First, explain the rock characteristic, investigation, drilling, and blasting. We apply the seismic refraction test to find the seismic wave velocity and depth of the soil or rock layers. And we calculate the rock U for rectangular drilling pattern. We learn 2 drilling pattern. We will talk about that in the later videos. And then we determine the resistance and minimum power source currents and voltage for electric blasting circuit. And the last one, estimate the production in terms of band cubic yard per hour, band cubic yard per hole of drilling, and the cost of the rock excavation. So in terms of the rock characteristic, go back to here, that quickly review what you learned in Geotech 1. We have 3 different types of rock. The first one, igneous rock, and this form from the earth molten material and cool down, and at that origin this rock tend to be very homogeneous and very hard to excavate. The second type of rock we call sedimentary rock, and this formed by the precipitation of material from the air or from the water, and because of that process, this rock is tend to stratify, have a different layer of fractions, and it's easy to excavate. The intermediate rock between the igneous rock and the sedimentary, that we call it metamorphic rock. And metamorphic rock are basically from igneous rock or sedimentary rock, but it changed due to temperature change, due to the chemical reactions, or it due to the pressure, so it changed to a different rock. So at the intermediate is rock also hard to excavate, but not as hard as excavate at igneous rock, and it's not as easy to excavate as sedimentary rock. And when we say about how hard to excavate, if you recall in Geotech 1, that measure by the relative hardness Mohs scale from 1, for example, torque, to 10 diamond. So for the rock that have 5 or less in that Mohs scale, so it can be excavated by ripping. So we can use knife to scrape the rock, and because that you can use knife to scrape the rock, so you can use excavator, hydraulic excavator, to excavate the rock that have Mohs scale 5 or less. So with that, we can be able to apply the lesson we learned in lesson 2-3 to determine that. Now, if the rock have 5 or more in the Mohs scale, what would we do to excavate that rock? And that basically the main topic of today's lesson. We have to drill, and we have to blast that rock. And of course, when that process involved, we need to do the seismic refraction test to estimate what is the depth of the rock, what type of rock is that. So let's go to the way to set up the seismic refraction test in here. For the seismic refraction test, first we set up the sound source, as you can see there, sound source. Okay, and then we set up at multiple point geophone, basically the receiver. So we send the sound from the sound source, and then it travel wave travel to different geophones, and it will be refract back to the sound source. That's why we call it refraction test. And with this process, we can measure 2 parameters. The first one, the distance, that easy, right? From the sound source to geophone, where you set up, you can find out. The second one is the time, send the signal, go back to the geophone, it reflect back, that we measure the time. So we have the distance, we have the time, and then we can be able to make a graph that called time distance graph, and that I'm going to show you now in here for the seismic refraction test. So we have the distance measure, we have the time, so we can draw the graph, and that we call time distance graph. In this case, distance in the horizontal axis and time in vertical. So as you know, the distance divided by time in the velocity is speed. So we can determine speed. Basically, that is seismic wave velocity. And that when we have seismic wave velocity, we can estimate what is the rock, how hard the rock is, how loose the soil is. Okay, so with that, generally it ranges from the velocity, the seismic wave velocity in the soil, soft soils, about 1,000 feet per second. It up to, for the hard rock, it can be 20 feet per second. And that different here, we can measure it if we have different layer, different type of soil, different type of rock. When you have those two information, and if we see, of course, normally the rock or the layer going down, it tend to be more density, higher density, and that implies the velocity tend to be increasing. So when that is the case, we can be able to determine the depth of the upper layer. For example, here, when the velocity increase, you can apply that equation where h1 is the thickness of the upper layer. Example, that is the upper layer there. Then distance from the south source to the first intersection of line on the time distance graph. So we can find out this one, d1. And of course, that we can measure based on your setup. And v1, v2 is the velocity based on the division of the distance over time, right? So we can velocity of the upper and the second layer. So with that 2 and square root, we can be able to find out the depth of the layer. And in the next lesson video, we will apply this concept, use seismic refraction test to determine two things. First, the seismic wave velocity and the depth of the upper layer.